Hey, my name is Sriram. I am a principal technology specialist at Microsoft. I have been working in AI and data technologies for over 20 years. This session is about AI landing zones. How would we create and develop Azure AI applications? So, you have been familiar with your application landing zone, the data landing zone, and probably, you have the same concept of landing zones in other clouds. So, think of landing zone as a specific subscription or a resource group that you're creating within the cloud, wherein you provide all the connectivity, security, tools, and cloud services for your developer to develop, tester to test, and your end users to deploy and use the final end product. So AI application is no different than any other data application or a web application per se. And last but not least, every landing zone needs connectivity to other landing zones. Just because Azure AI Landing Zone typically is used to create AI applications or AI endpoints, which could further be used within your data applications and web applications in the context of data movement, data consumption, etc. So, with that, first let's try to understand what are the different components that need to be in this landing zone. So, in order to develop an AI application, first you need tools. In order to create the AI APIs, we need tools such as prompt flows, which are part of AI Studio. So, AI Studio is a tool that brings together several personas, such as AI developers, machine learning programmers, data scientists, um, database developers, application developers into a single umbrella. And you will see all of the components in the next part of this video at a greater detail. But now, think of AI Studio as the tool platform wherein, bunch of other tools are available in order for you to create an AI application or an AI API. So the next aspect is prompts. Prompts are heart of AI API. The better your prompt is, the better the AI application or the output of the AI application. So prompt need not be static. Prompts can be static, which are meta prompts, and we'll discuss more about it. But also prompts can be dynamic, wherein you will infuse data into the prompt at runtime so that you ask using the prompt, let's say, the result or output from a large language model. You will be developing some code base, whether they are Python notebooks or Python code, in order to infuse the prompts into and make REST API calls to all these large language models and vector databases, etc. And therefore, you need a repository. And in this case, it could be a GitHub wherein you store everything, or Azure DevOps, whichever path you want to take. Also, you have a bunch of AI services such as vision, speech, bot services, etc., that go along with the large language models in order to, let's say, create a chatbot or to create an intelligent vision API or an intelligent speech API. And those services are definitely part of something called Azure AI services, and you do need them along with any large language models or small language models. Also, on the compute side, you need actually a compute to actually run, example, your API itself, or you want to actually run a version of the small language model, and that compute should be part of the landing zone. Usually, last but not least, you need Azure OpenAI models itself if you are taking advantage of Azure OpenAI or any of the open source models or language models, like or any other non-generative AI models which Microsoft made available in form of model catalog. Also, you will be needing vector databases, and you will soon know in one of the videos that I will be doing in this series. But for now, like as AI Landing Zone creator for infrastructure persona, all you need to understand is you need to create something called a vector database. Vector database is typically used to store some uh, data types called vectors, and those are, for now, just to make life easy, think of them as a list of numeric values that you will be storing, and you will also be retrieving a lot of information using the same list of values. So these are not traditional databases. In some cases, such as Postgres, it's a extension of Postgres SQL database, or we offer our own AI search as a vector index, and also you could use any open source vector databases such as Pinecone, right? So Sky. Let's see in this video Azure AI Studio architecture itself and how you will be connecting various components. So your enterprise will have your own network, and you will be connecting your network to Azure, of course, through site-to-site VPN, or using something called Express Route Circuit. So once that connectivity is established, whether you are in the cloud or whether you are in your enterprise, you actually will have access to an Azure subscription and in turn a resource group, wherein you have a bunch of AI tools that are needed for you for the development of your application. So as we discussed in the last video, AI Studio is one of the key components, and therefore, the idea is to terraform all the components that are needed in order to not only create AI Studio components, but also to make or establish connectivity to other resources that are key to develop your AI applications. And also, we need to understand what are the different components of the AI Studio itself, and how actually you can block the internet access, so that either the user interface of the AI Studio itself could be blocked from the internet, or the components such as compute and like the APIs, etc., would be blocked from internet. Also, we will be seeing how you will be connecting various components such as Azure Storage, Key Vault, connection to other Azure AI services, a container registry, search, etc., to actually secure them and connect them to the AI Studio. So AI Studio comprises of, of course, two parts. Think of them like that. And in fact, there are three parts. One is the AI Studio portal itself, where you can see everything. So what is everything? Everything is hub and a project. So a hub is typically used to maintain such resources as compute, and any other connectivity to other services, which are pretty much done once, and make available to something called AI projects. So think of AI projects as a workspace where a developer could develop, test, and productionalize their artifacts. And as part of AI Studio, the AI Studio takes advantage of all the connections and compute that is made available as part of AI Hub. And also, you will be using a bunch of constructs in AI projects, such as notebooks, prompt flows, wherein You can segregate your notebooks. You can segregate the APIs you create. You can segregate the prompt flows you create in order to productionalize your prompts for your AI applications, all within AI project, your AI project, which serve as the development boundary for your use case. So you can secure uh, the AI hub and the AI project within a managed virtual network. So Microsoft actually maintains the virtual networks. We manage it for you. You don't need to actually, like create your own VNet and make that VNet join to these services. But instead, you create a managed VNet with a single click of button if you are using Studio Experience, or with a single attribute in Terraform template, so that you can secure all of these components within a managed network. And you can, let's say, for example, manage outbound connectivity, right, to internet, or you can completely block the inbound connectivity, right. So these are some of the things which, when I show you, they'll make total sense in greater detail. But this is the managed VNet portion. And secondly, in order, for you to connect other secured components, for example, your Azure storage, your Azure Key Vault, they themselves could be actually secured using a virtual network, which I'm showing here, right? So when you block internet connectivity or public connectivity, you have to actually establish a private endpoints. So that is no different, right? So for example, in context of managed VNet, in order for the VNet, right, to reach or to make an outbound connectivity, this is not internet, this is your virtual network, because these services are within your virtual network. What you need to do is you need to establish that secure outbound connectivity through something called managed private endpoints. So we have actually several things, that we ease up for you, because this is a managed network. You just establish outbound connectivity to all of these, depending upon, how much you choose to secure or not secure. So when I show you the Terraform templates, these things will become clear, right? And also, don't forget the AI Studio, which is the interface or a portal to log in, which is ai.azure.com. That itself could be secured. That itself could be secured within your virtual network, right? Which means no one can access it outside your company, right? So when your developer logs into the laptop in the enterprise, and if they say AI Studio URL, then instead of hitting a public endpoint, it will be hitting a private endpoint that is borrowed from your virtual network. And you could either use your custom DNS or Azure DNS in order to actually create that awareness. When a developer calls the AI Studio URL, then which private IP address it corresponds to is established by which virtual network it is part of, and what private IP address it got from there, and that VNet being connected to Azure Backbone, it knows that it needs to go here, and all of that is done by Azure DNS. You can also do your custom DNS if that's the approach you want to take. And also, since all of these storage, let's say Key Vault, AI services, they all can be secured using your own virtual network. So obviously, all of these should be accessible, and this should be your current path, right? So you already know how to establish this link to storage from your VNet, etc. That is nothing new. So you will actually, deal with RBAC using Azure Active Directory, as I mentioned. So which is actually the cleanest way of doing that. And also you can integrate you can actually integrate Git and other conda packages. Let's say you even block the outbound access. Then what we do is we create a managed firewall um, to poke a hole within the managed VNet wherein you could reach to, like conda packages or Git. That is very advanced. Most of the companies uh, don't actually necessarily sever the outbound access and make it isolated. You can, but I wouldn't go that far. Just because this managed firewall costs money because Microsoft manages that firewall, right? And you need actually you can allow outbound access to internet, and many companies will not have a problem. But nevertheless, you have both options, and you can isolate everything, and you can even block outbound and therefore manage connectivity to such components as Git and Conda using managed firewall, which we maintain because it's a managed VNet. So with that said, this is actually Azure AI Studio architecture and all the security and network components corresponding to that. And in the next video, we'll jump into the Terraform components themselves and see how to do this. Thank you.